Good evening, Harshit. How are you? Harshit, how are you? I can't hear you. I think, Harshit, your voice is not reaching to me. Just log out and connect again so that, Harshit, I can hear your voice.
Ma'am, can you hear me?
Yeah, Harshit, I can hear you now. How are you? Yes,
I'm
Harshit.
fine, ma'am.
Okay. So, Harshit, you have not written the yesterday's test. Why?
Ma'am, maths test wrote.
Science test you did not write. Hmm? Science test was also there.
Okay, ma'am, I didn't saw.
Okay, every week you will have like every Sunday you will have the maths also and the science also. Okay, so every week you should write it.
Okay, ma'am.
Yeah, okay, Harshit. Good evening, Neha. How are you?
Good evening, ma'am. I'm fine. How are you, ma'am?
I am also good. Thank you so much. So we'll wait for 1 or 2 more minutes so that we can start with the next topic of the chapter, Fun with Magnets. And the topic which we'll be discussing today is the properties of a magnet. So, what are the properties of a magnet and how do they work? So, let us wait for a few minutes. Maybe Adya and Bhavesh will join.
Okay, ma'am.
Okay, children, turn on your videos now. Turn on your videos. It's like after so long, I'm watching you, I'm seeing you. Bhavesh, turn on your video. Harshit, you also need to turn on the video.
Ma'am,
I can.
from tomorrow onwards, I'll do.
Okay, all right. Okay, so last time actually we have discussed about the maglev trains, and we have also gone through the videos. We have seen so many related things to that. So it works on the on the basis of the electromagnets only, and the speed of them increases because of that. So they will have the space between the down part and the upper part of the train, and it is the magnet which makes it run faster. And now in the today's class we will be discussing about the properties of a magnet. What are the different properties, how does they work, and some of the properties we have already discussed. So now if I talk about the magnet, any one of you can tell me like where the magnets work. Does it work in the water?
No.
No.
No,
Bhavi,
ma'am.
okay, you are saying that it will not work in the water. Okay, does it work in the air?
Yes, ma'am.
Yes, ma'am.
Then why don't it work in the water?
Ma'am, it does.
It does actually. It does work in the water. So be it air, be it water. So if you keep those two magnets in the water also, they will be attracting. Fine. And then maybe, you might have heard maybe in the news, or you might have seen in the news, like we have the Ganga River, right? Ganga River, Yamuna rivers, all those rivers are there. So the people, they will be throwing so many coins in that, right? Making the wish, and then they will be throwing the coins in that. So what happened? Ultimately, some of the people who stay near to that area, what do? They will be using the magnet, and then they will be taking whole a bunch of coins through that magnet, right? Have you seen?
Magnet fishing also, ma'am. Magnet
Uh,
fishing.
Harshit, come
Magnet
again,
fishing.
Harshit. Harshit, say
Ma'am,
again.
magnet fishing. Magnet fishing.
Yeah, magnet fishing, it is also called as. Correct. Very good, Arjit. So that's what actually, if the magnet does not work in the water, in that case, they cannot attract it, right? But they are pulling it. It is because of the magnet. So magnet does work in the water as well as in the air. So normally, right now, like if I have the two magnets, if I wanted them to attract, they will attract. The same thing, same magnets, if I'm keeping inside the water and I want them to attract, they will be attracting. So that is how it works actually. So even if I talk about the television, in the television also magnets are there. In that television magnet, if I attract some other magnet, it will be attracting, right? So be it, or you might have, the pencil box you will have. The pencil box have a kind of magnet when you open it,
Yes, sir.
right? So that
Yeah.
that is also solid, right? Because of that, you are able to close the flap of that box, right? So it works in the solid also, it works in the air also, it works in the water also. So if any object, yeah,
Ma'am, magnets are even present in debit cards and credit cards.
correct. In
From
the
the
credit
magnetic
cards
strip.
also, debit cards also, it is present, right? That is why what happened, easily through that chip, easily they can get those radiations, and they will be working on the basis of that. So whatever the objects you have, if you keep them near to the magnet, they will start, applying the forces there, and because of that, they start working. Start this showing the magnetic effect towards it. And that is why, if you don't want them to attract, what you should do, you should keep them away, then only they will not be attracting. So this is the first point, that magnets will be exerting their influence through various media. So whatever the medium are there, so the magnetic effect will be there. Okay, so let's write first of all first point. Are they, am I clear to you? The first property of the magnet says that whatever the medium is there, if we keep the magnet in the water, it will attract. If we keep the magnet in the air also, it will attract. And if we keep it in the solid also, we are talking about, it will attract. Okay, Adya? Adya, your voice is not audible to me. So today's topic is properties of magnet. Now, talking about the first property, as like just I have said you, magnets exert their influence, their influence through various media. Media means here medium. It is not about the TV media, okay? It is about the medium. So in the medium also, what happens in any medium, solid, air, or maybe the water also, in the liquid also, what happens? The force will be there, the magnetic force will be there. So the effect of magnet, not magnetic, effect of magnet works through air. It can work in the air, it can work in the water, and even through some solids. Not all solids, some solids, depending upon the type of it. Like I have given you the example of the pencil box. So pencil box, in the front of that, to close it, you will have the magnet. So with the help of magnet, it get closed. Then we have the purse also, like, right, the girls will be carrying the clutches or the purse. So that also has a magnet. Because of that, it get locked. Then next point, an object very near to the magnet, what do? They experiences more force. So if any magnet are being kept very close, so they will be experiencing the magnetic force more as compared to an object kept away. So two things are there. If they are kept close, like for example, now here we have A magnet and here we have B magnet zone. Okay, so they are kept very close. So what happened there? You will be noticing the magnetic force will be created there. But at the same time, if the A point is here and then B magnet is here, so magnetic force will be very, very less in this case, or it will not be there at all. Because the distance has been increased, that is why they do not have the power to, make out the force there between the A magnet and the B magnet. Understood, Harshit, Neha, Bhavesh, and Adya?
Yes, ma'am.
Okay. Now going to the next point.
Ma'am, can you keep the before slide?
Okay, this is a before slide.
Yes, ma'am, over.
Over. Okay, next one. Now, second point says that the freely suspended magnet always comes to rest in the which direction? In the
North-south direction.
very good, Neha. In the north-south direction. So when any magnet we have, if we are keeping it like freely suspended, if we are keeping it, then what happens automatically? They will be coming to rest in the north-south direction. So write this down, then we'll go ahead. Now here, why it happens actually? Why, this freely suspended magnets, when they are in the rest, why they come only in the north-south direction? So we will be discussing the reason about it. So talking about the reason, now what happened? So it happens due to the Earth's magnetic field.
Ma'am, your
So
voice is breaking, ma'am.
my voice is breaking. 1 minute. Now am I audible to you?
Yes, ma'am.
Okay. So the reason why it happens because of the Earth's magnetic field. Now, what is Earth magnetic field? We will be discussing. Now, see, if I talk about the Earth, Earth itself is what? It is a huge bar magnet. So, Earth itself acts like a huge bar magnet. Huge bar magnet with its magnetic pole, with its magnetic north pole near the geographic north pole, and whereas its magnetic south pole will be near to the geographic south pole. So magnetic north pole will be near to the geographic north pole, whereas the magnetic south pole near the geographic south pole. Fine. So this point you should understand first of all. So Earth itself is what? Is a huge bar magnet. Its magnetic north pole will be near to the geographic north pole, whereas the magnetic south pole will be near to the geographic south pole. Now, what happened in this condition? The magnet's north pole. So, what the magnet is there with the north pole, automatically with whom it get attracted with. So, magnet's north pole is attracted to the Earth's magnetic south pole. Earth magnetic south pole. Now, why it happens? It happens because always we know that north will attract to the south and south will attract to the north. So that is why the magnet north pole will be attracting to the Earth's magnetic south pole, causing it to. So because of this, what happened? It south pole, causing it to point northward. So because of this attraction, what happened? It start pointing northwards. And that's the reason that the freely suspended uh, magnet will be coming to the north direction in the rest position. So when the magnet's north pole is attracted, it will get attracted where? It will not get attracted to the north pole only. It will get attracted to the Earth's magnetic south pole. So that is why it happens the attraction here. If we are taking only a same pole, like if I say magnetic south pole and the Earth's magnetic south pole, then whether the attraction will be there? No, right? So that is why the magnet's north pole will be there. It gets attracted to the Earth's magnetic south pole. So because of that, whenever it comes in the rest position, it will be north-south direction.
Ma'am, is there really a bar magnet inside an Earth?
See, nothing like that. It's imaginary line, the axis.
Ma'am, can you put the previous slide?
Okay. So here, complete the statement also. It will be aligning with the So once done, let me know so that we can go to the next point.
Okay.
Can you take the next slide?
Yeah. Done with this page?
No, ma'am.
Okay, do it fast.
Ma'am, on the previous page, isn't the magnetic North Pole near this geographical South Pole?
No, see here we are talking about the Earth actually, not about the normal magnet. So, but when we compare it, then in that case it becomes the opposite.
Means North Pole will indicate South Pole and South Pole will indicate North Pole.
Come again, come again.
Ma'am, means the magnet will indicate the Earth's magnetic South Pole will indicate Earth's magnetic North Pole, and North Pole will indicate Earth's magnetic South Pole.
Correct. It's opposite actually. So then only you will be finding the attraction, right? So that is why it is opposite. But here in this paragraph, they are talking about the bar actually, the bar magnet of the Earth. In that case, that bar will have the North Pole and which is near to the North Pole of geographical North Pole. Whereas the magnet, that bar magnet of the Earth has the South Pole near to the geographical South Pole. But when it comes to the attraction of the other magnet, in that case, definitely the North Pole will be attracting to the geographical South Pole of the Earth. Clear? Neha, understood? Here in this paragraph, they're talking only about the Earth bar magnet, not about any other magnet.
But the compass will show the North Pole as the South Pole and South Pole as the North Pole.
See, compass, that is different. When we talk about the compass, that will be showing you the different direction actually. But in reality, when we talk on, it will be the Earth, whatever the Earth has the North Pole, the opposite of that will be have the South Pole. So if our magnet, like if I talk about the compass, if it is showing the South, there it will be actually the North.
Ma'am, finished, ma'am.
Okay, now next point, we'll go to the third point, which is we have studied so many times that like poles repel and unlike poles attract each other. So like pole, they will be repelling, and unlike pole, they will be attracting. So we know very well the North Pole will be there. They will be attracting what? They will be attracting the South Pole. Whereas the South Pole will be there, they will be attracting the North Pole. North Pole. Here, pole. But if it is north to north or south to south, there will be no attraction. In this two case, when north and north is there or south Oh, wait, here I have written wrong. Here, south and south is there, and north are there. There will not be any kind of attraction, and they will show the repulsion. So that is why to have a magnet, if you have a magnet, the north pole will be attracting to the south pole, and the south pole of a bar magnet or any other magnet, they will be attracting towards the south pole of a magnet. So that is what the next property, third property, that like poles will be repelling and unlike poles will be attracting. Like means same kind of pole, like north and north or south or south. Unlike means different kinds of pole, which means north south or south north. So last property also let me complete and then you can write. The next property is magnetic poles cannot be isolated. What do you mean by cannot be isolated?
Ma'am, cannot be separated.
Okay. So magnetic poles cannot be isolated, means separated, which means we have the two poles as we have discussed, north and the south pole. So if we wanted that, we should get not all the north separately and all the south separately, that we cannot do it. In actually, what happens if we cut a magnet, for example, if we cut a magnet, okay, or if we break down a magnet into two parts or more parts, into two parts or more parts, we cannot isolate. We cannot isolate. So if it is three parts, four parts, six parts, whatever the parts are there, we cannot isolate, which means we cannot separate the north and the south pole. So if we want that all the north pole should come one side and all the south pole should come on one side, it is not possible at all. Here, each piece, so whatever the piece we have got, each piece has its own individual, yeah, correct. So it has its own individual north and south pole. So if I suppose, for example, children, I have this bar magnet, okay, and what I did, I have broken it into three pieces, might be. Now these three pieces, like here, these three pieces will have what? North and the south, and north and the south, north and the south. It is not like that if they have broken into three pieces, they will have only the north or only the south. No, they will have both north and south, north and south, north and south. So it is because always, why it happens? So it happens because always magnetic poles exist in pair. Why it happens? Because the magnetic poles always existing in pairs. So if it is broken into 5 pieces, 10 pieces, 15 pieces, they will always be in the pair. So north will be always with the south. The south will always be with the north. It is not like south and north, south and south, north and north. No. So the reason is this, because magnetic poles always existing in pairs. They always be in pair. That is the reason. So this is the fourth and the last property. So write it down now from the third property.
I'm done.
Others also have done?
Ma'am, just a minute.
Okay.
Done, ma'am.
Okay, next page.
Ma'am, done.
All have done? Okay.
Done, ma'am.
Next one.
Ma'am, all are done, ma'am.
Okay, that's good. Others also completed?
Done, ma'am.
Okay. So these are the four properties of the magnet. The first property is, it says that the magnetic force can come into any medium. It can be there in any medium. It can be the air, it can be the solid, it can be the liquid also. Then whenever we are keeping any magnets close, they will have the more magnetic force, and when we keep them apart, then either the magnetic force will not be there, or it will be very less. Then the second property says that if we leave them in a freely suspended way, then always they come in north side, north south direction. It is because of the Earth magnetic field. Then the third property says that like poles will be repelling, unlike poles will be attracting. And the last one, it says that if we try to isolate the magnetic poles, we cannot do that because they always existing in pairs. They always remain in pairs. Fine, children. Now for today, you might have seen, I hope like you might have seen that I have shared some extra question answers related to the chapter Fun with Magnets. Have you gone through them?
Ma'am, not yet. I'll
Have
go
you
through them.
seen? Okay, but you might be knowing, right? I have shared the extra question answers.
Yes, ma'am. I saw it in the book.
Bhavesh, have you seen that? Harshit, have you seen that in the WhatsApp group?
Ma'am, no, ma'am. I was preparing for exams.
Okay, no problem, no problem.
I have
So I
exam.
have, okay. So I hope my screen is visible. I have shared you these questions. It has 10 short questions and 10 long questions with the answers. Okay, I have given you the answers also. See, the reason why I have given you answers so that you'll know how to frame the answers appropriately, right? Sometimes you feel like we are not writing in a proper way. Sometimes you feel like we are writing it. So that's the reason that I've given you the answers also. Okay. So long answers,
Ma'am,
don't
should we
few
write this?
no, don't write it. Okay, if you want, you can take the printout of it, but don't write it because if you write it, then might be you need some 1 hour to complete it, right? If it is possible, then you can take the printout. If not possible, maybe then daily two questions you can write. Okay.
Okay, ma'am.
So most of the things like we have already discussed. Like question number one, why is a freely suspended magnet always point in the north side direction? Then question number two, how can you determine the poles of an unmarked bar magnet using a second bar magnet? Third, what are magnetic material? Fourth topic we have to discuss actually. Then apart from that, we are done with sixth, seventh, eighth, we are done. Question number 4 and 9, we will be doing it soon. Then question number 12. So almost like out of 20, I guess 15 we are done with. Okay. So we are just remaining with few topics of the chapter. So once like uh, maybe in the next class or next to next class, I will be completing your those topics also, whatever they are remaining. And then now I'll be taking the children, turn on the video also. So what now I think a slight change is there in the timetable also. Earlier it was Tuesday science class for you. Am I correct, right? But now it will be maths class for you. Okay, tomorrow permanently, like. So tomorrow you will have the maths class, and then on Wednesday you will have the science class. And for the science, the other teacher will be teaching you. Okay. Now I will be taking bio for you. She will be taking physics and chemistry for you. Okay. But I will be completing this chapter actually. I'll be completing, since I have started, let me complete this chapter, and then she will be taking forward your chemistry and your that part, and bio I'll be taking. And I think you have completed the body movement chapter, I guess, and components of food also I think you have done with. Right? So we'll be going with the chapter getting to know plants once we complete with fun with magnets. And in that chapter, so many practical activities are there, like
Harsha ma'am started.
getting to know plants started. What she has taught you?
Ma'am, she has taught different types of plants, herbs, shrubs, climbers,
Trees,
creepers.
climbers, or creepers. Okay, okay, fine, fine. So we'll be discussing those, and at the same time, in this chapter, I just wanted you to do the activities rather than learning it orally, or learning the theories. Like you will be explaining me by taking the leaf, you will be explaining me the structure of the leaf. By taking the flower, you can dissect it. Do you know what is the meaning of dissection?
Ma'am, cutting it into half.
Not actually half, actually removing the parts of it. Okay, that is called as dissection. So if you have any animal or any kind of the plant and all, when you remove their parts, that is called as dissection. So that also you will be doing in the class. Apart from that, there is an activity which is like, to study how the color changes, how the conduction of water happens in the flower. That also we will be doing in the classroom actually. So in that, you will be taking the red ink or the blue ink, and then you will be cutting the stem into two from the center, and one stem, one part of the stem will be in the one color, the second part of the stem will be in the second color. So what happens, slowly and gradually the movement or the water will be going from down to the color, from the colors to the upper flowers, and the color of the flowers also will change. So like this. And then you have the one more activity which is like, I don't know whether you did or not. In my childhood I did it, tracing, right? Tracing part. So without touching the leaf, how can you identify, like, how it is? So by tracing. So you have to keep the leaf, and on the leaf then you have to keep the paper, and you have to actually trace it, or you have to just do like this with the help of the pencil. So that activity also will be doing. And then so many activities are there actually. So bio is full of activities, full of activities. So we'll be doing so many activities. And the body movements, you had the activity to make the boat. So how to make a boat, and when when you keep it in the water, it will be moving in a particular direction, right? It will move in straight or zigzag. It doesn't move like zigzag, always in a straight. So it is because of the streamline. So that activity was there. So let me complete it fun with magnets, and then we'll be moving to our practical part rather than the theoretical part. All right. And if in case you have any doubt, message me, I'll clarify those. Okay, children. Thank you.
Thank you, ma'am. Have a nice day.
Thank you. Thank you. Thank you, Neha.